So, hello everyone. Today we are going to solve a few questions from Codeforces round 797. So, here's the first question. So, this was print a pedestal. It was a very easy question. You are given a number n, and what you have to do? Basically, you have to write and divide n into three numbers such that three numbers h1, h2, h3 such that h1 is greater than h2 is greater than h3, and you have to try to minimize h1 as possible subjected to these conditions. So how we are going to do the question? So the constraint was the n is greater than equal to 6. So when n equals to 6, the obvious answer is 2 3 1. So basically you have to print, you basically have to output h2 h1 and h3, right? So the answer was 2 3. But how did we come to this answer? So now for this case, when n equals to 6, n is divisible by 3. So in that case we made the answer 231. Now what if n was equal to 7? So let us try to create the answer of n equal to 7 from n equal to 6. So what we'll do, we'll add, so we cannot, so the answer will be same as n equal to 6, but just we have to add 1 to one of these numbers. We cannot add 1 here, we cannot add 1, we can add 1 here, we cannot add 1 here. So the answer for n equal to 7 is 241. Now for n equals to 8, what will happen? So for n equals to 8, what we can do is we can add 1 to these two, and the answer will become 341. So basically when n mod 3 equals 0, so when remainder when n divisible by 3 is 0, so answer is n by 3, n by 3 plus 1, and n by 3 minus 1. So and when this mod is 1, it's the same as the above, just we add 1 here, and when it is equal to 2, we add 1 to the first element, and we add 1 to this element. So this is the answer. So I guess question 1 is clear. Implementation is quite easy, so I will skip the implementation. Now to the next question. So this is array decrements. So in this question you are given to an integer n and an array and two arrays of size n each. So you are allowed to perform an operation. In one operation, what happens? You take all the non-zero numbers from A and decrement it by 1. So your task is to determine whether in finite number of operations can A be converted into B or not. So okay, so how to approach this question? So what we can directly do is like, so if we know that if AI is less than BI, any element AI is less than BI, we can never ever convert AI the array into BI. So basically we'll run a loop, and we'll store the difference of corresponding element in an array. If the difference is negative at any point, we'll just break from the loop and print no. Else we'll try to find the difference. Now we take the maximum of the difference, and then again run a loop and check whether AI minus BI equals to equals to maximum of the diff. If it is equal to the maximum of the difference, then it's fine. But if it is not equals to, then we want the element BI to be 0, because so for example we have this case 2 0 and 4 1. So A is at 2 comma 4 and B is 0 comma 1. So we can convert this A into B because the max difference is 3, and whenever we encounter a difference smaller than 3, that is 2 over here, the other element should be 0, because how A will be converted into B? A will be 2 comma 4, in one operation it will become 1 comma 3, then it will become 0 comma 2, and then in the next operation it will become 0 comma 1. So in 3 operations the array A can be converted into B, and it is only possible if the difference of all the elements is equal to the max difference which we calculated earlier, or if it is not, then the BI of the corresponding element must be 0. So even this question is easy, and the implementation is pretty straightforward. Jumping to the next question, restoring the duration of task. So in this question we are given start indexes of some tasks, finish indices of some tasks, and what we have to do is so there is this guy in the question, Polycarp, what he does, he he's sitting, he is doing, is chilling around. Whenever he gets a task, he starts that task and try till its finish time. But if any task arrives before that, he just queues it up in a queue. So basically, we have to find the time required to actually complete the task. So what I did, and in the question it is given that the start time of all the tasks are different. So basically, what we can do, we can so what I did in the question, I made a I made an array of tuples where I store corresponding start index and finish index of the task, and I sorted this array. So basically, I got an array of a task such that the I got an array such that the tasks are sorted by the starting indices. So basically, now the question is simple. So what we will do, let us define a variable current time which is equal to 0. This will be our starting time. So I will loop over all the tasks in SF start, and what I will do, so my current time will be equal to max of uh, current time comma SF's the starting time of the current task. So why do we do so? So suppose we are at time t equals to 10, and a task arrives at 12 and it gets over at 20. So basically, to calculate the time required for this, what I will have to do, I will have to do 20 minus 12. So basically, what here I am going to do, I will make current time as max of current time and s of I, and then d of I is equal to end time, finish time of current task minus current time. And why this is necessary, because in this case, so 20 minus 12 will give me the answer. Now suppose that the current time is 15, and suppose the current time is 15 and I got a task of 12 comma 20. So basically, to get the for this task, we are going to need 5 seconds. So during this update, we can get during the update of current time is equal to max of current time comma sf of I will get it done. So so the overall implementation is, so I sorted the array. I have the current time variable. So for I in range n, so current time is equal to max of current time comma start index of ith task. And so duration of this task is equal to finished time of this task minus finish time of this task minus current time. So this is the duration required for the task, and what I will do, after this step, I will update the current time to the finished task, and similarly I will print all the ts, and that is our answer. So I guess this was also a pretty straightforward question. Jumping to the next question. So next question was black and white strips. So in this question, we are given a strip of a strip of black and white uh, squares. So basically, this is white, black, black. So what here? What we can do here in this question? What we can do? We can take a white strip and convert it. We can take a white strip and convert it to a black strip. This is operation. This is one operation we can do, and we have to determine whether uh, what is the minimum number of operation required to convert to have a contiguous black strip of length k. So n is the length of the strip which is given in the question, and k is the desired length of the black strip which is given in the question. So you just have to find it. So one trivial approach is, we start from n equals to, we try to calculate this for every strip of length k. So I will, so suppose that k is equal to 3, so I will calculate for this strip. Then in another, so I will run one loop as for I in range n minus k. So because there will be n minus some n minus k plus minus 1 amount of strips in the question. So if n equals to 5 and k equals to 3, so we have n minus k plus 1 number of strips in the question. So what we'll do for one trivial approach is for I in range n minus k plus 1 and in the other loop I will run a for loop of length k from I to I plus k, and from I to I plus k I will count the number of white strips, and I will store and I will store the minimum of all those white strip calculated. But this approach will cost us because the running time will be n into roughly n into k, and this is and given the test cases both n and k are of order 10 raised to 5. So the total running time will go 10 raised to 10, which will throw a time limit exit error. We'll use a smarter approach. So I use sliding window approach, and during the solving session yesterday they also mentioned a prefix sum approach. I will explain both of them. So by a sliding window approach. So what I did, initially took the first I defined a variable minimum, and another variable current minimum, current whites. So what I did, I took the first strip of length k and calculated the number of white elements in this white squares in this, and while sliding it over the while sliding it, what I did, so I will take this above example. So suppose I have white black black white, so the length is 7, and suppose our k is equal to 3. So what I did, I took first three elements, so I had calculated the number of white squares in this, so that is 1. So my minimum is set to 1, and my current white is set to 1. So when I slide this window over here, what happens? So I am adding a white element, and I am removing a white element. So essentially there are no change in this step also. Even in this step I will require exactly one step. So what I did, uh, so if so for so first calculated this for the first k elements, calculated the minimum these two variables, that is minimum and current white. And what I did, I ran the loop from n equals to 1 to n minus k n minus k from 1 to n minus k plus 1. Let me check if it is n minus k plus 1 actually. I ran this basically I ran this loop, and after this what I did, so if for I, so if my I minus 1th element is white, so basically so basically what happened previously, my strip was like this, and because I am removing this element, I subtracted current by 1, and the next element, and if the next element is white, so my I plus kth element is white, so I added sorry, I plus k minus 1th element is, so this is I equals to 1, and this is and this is index 3, so I plus 3 minus 1, that is uh, 1 plus 3 minus 1, that is the third element. So if I plus k minus 1th element is white, I added white to my current, and then I wrote minimum whites is equal to minimum of current comma minimum. So base, and in the end I will print this variable which will give me the answer. So this was the D question. Now the next question are a bit tough. So this is price maximization. So also the implementation of this question is also a bit tedious. I will share the link of my implementation uh, in the description of this video. But yeah, let's go ahead. So in this question, there is a batch of n goods, and it is given that n is an even number, and each good has some value associated with. So there are n goods, and n is an even number, and each good has some value attached to it. Basically, its weight is attached to it, a1 up to an, and we are given another element k, another integer k. So what in this question, what we have to do, we have to pay, we have to make n by 2 we have to make n by 2 pairs of these goods. So like if we are given something like 1 2 3 4, you can like pair 1 and 3 and 2 and 4, and we have to pair, like you can do it arbitrarily, but you have to pair in such a way that uh, so summation uh, so for every pair I made, so ai plus aj is the weight divided by k, and the floor function of this will give me the floor function of this will give me the give me the uh, give me the value of this package. So basically a floor function of the sum of weight divided by the integer k will give me the value of it. Now our task is to pair this element such that the value is maximized and we have to print the maximum value. So how will we do this question? So first of all, what we should so first of all, when I tried the question, like I couldn't do it during the contest, but later when I tried, so I saw that uh, k is bounded by 1000. Like the number, like the case bounded by 1000. And second thing is, so what is the value you can definitely get from every element? So if I write uh, ai so if I write ai divided by k, like if I get the quotient, so for every element a1 up to an, I am definitely going to get at least this much from the element, no matter how I pair them. I will explain with the test case. So example, this test case, 4 comma 3, n is 4, k is 3, and this 2196. So the elements are 2196. So from this element, I will get 2 divided by 3, that is 0. I am talking about the question of 1 divided by 3, 0. From this element, I will at least get a value of 3, and from this element, I will at least get a value of value of uh, oh sorry, this is 9, this is 5. So my bad. So I will explain the example again. So for this test case 2156, from this element I will at least get a value of 0. From this I will get a value of 0. From this I will at least get a value of 1, and from this guy I will at least get a value of 2. Now now if we concentrate on the remainders, so I will just write the remainders 2 1 2 0. So now I am left with their remainder. So basically I took the quotient from it because that much value I am definitely going to get. So I can declare a variable answer and loop over all the elements and take answer plus is equal to ai slash k, and I store their quotient in a different I store their quotient in a different array. So now what I can do, now I have their quotients. Now what I can do, I can try to pair these two elements, and if I try to pair these two elements, so basically I will get another value worth 1 because at k equals to 3. So if I pick two elements whose quotient like whose remainders sum up to be k or greater than k, I will get additional value. So basically if I pair these two up, I will get additional value. So overall my answer, so for this, if I pair these two elements and these two elements, I will get my value as 4, which is maximal for this question, no matter how you pair. Now the question is, you can calculate the quotient part, but how are you going to pair these elements? So so what I did, uh, so I made an array mods of size k, indexing from 0 to k minus 1. And if I get an element whose mod is I incremented it by 1. So in this case our mods array will look like uh, so 0, so our k equals to 3, so our mods array will be of size 3, and there is no element of mod, there is one element of mod 1, but those are irrelevant for us because you cannot like pairing it with anyone else won't pairing 0 with someone else won't increase their value by k. So there is one element of size this, and there are two elements of with mod this. Okay, so now what I did, so this was so I basically made this mod array. Now after that what I did, these elements are irrelevant. I started from this element number one, and I did a binary search in the remaining part of the array. If there exists an element which is if I did a binary search in the array, if there exist any elements whose mod is uh, does there exist any element whose mod is n minus 1, sorry, whose mod is n minus I, sorry, k minus I, because my current element is I. If there exists an element whose mod is k minus I or greater, uh, k minus I or greater, so I can pair these two up and basically my value will increase by 1. So I did this. So I did this for all the elements, for all the elements from 1 to uh, from 1 I did this while I is less than k minus I, and when now I am only left with elements who are greater than k by 2, so I can pair any two of them and I get uh, like, so if I have ai and aj both are greater than k by 2, greater than equal to k by 2, then ai plus aj will be at least k, so I will get another one value from them. This is what I did. Now the implementation is bit tougher. I will post the link of my implementation in the description. You can check it out, and maybe if you are doubts, you can ask them again. So this was this question. So the overall time complexity of the question. You will need to run a loop over all the n elements to check to get the frequency table of modulo, and you will also need to run like to check for this case. You will have to run this loop by k into log of k times, because you are doing a binary search and we are doing it k times, so k log k. So the overall complexity is n plus k log k for this question. So I guess this question is a bit tough to understand. Maybe you might have to watch through this part again, and implementation I will share it. So moving on to the last question which I was able to solve, I couldn't solve. I'm still trying to see. So F's question is a shifting string. So in this question, shifting string, you are given a permutation of n, permutation of length n, and a string of a similar length. So basically, a permutation of n is an array A, such that no elements whose size is n and no elements repeat, and all the elements are from 1 to n in any possible order. So that is the permutation. Uh, Let me just open. Yeah. So this is so basically what our task is. So every time what happens, so suppose we are given a string a b a b a, and the permutation is 2 1 4 5 3. So what happens, so every time what happens, then element at a, so at index 0 the permutation has 2, so the element of a element, so it is considered in one indexing. Let me write the index. So what will happen, the element at a will go to wherever the index 2 is, so a will go over here. Wherever there is b, b will go to the index 1, so it will go over here. And this guy, similarly, this guy will go here, this guy will go here, this guy will go here in one step. So basically you have to check how after how many minimum number of steps the string will become what originally it was. So in order to find this, so basically this is a permutation question, and remember always that in permutation question, there will always be these kind of cycles forming. So basically what to find how many minimum number of steps what I did. So basically we can look at this as two separate questions. I will consider this string separately and this string separately. So this string is AB and this string is ABA. Now after how many steps will this string be back to normal? So after one step it will become BA, after another step it will become AB. So after two steps this is becoming what it originally was. And similarly for this string it will become AAB, BAA and ABA. So after three steps it is changing, coming back to original. So the entire, so this was individual. So the entire original string will take LCM of these two numbers to come back to the uh, original, like LCM of 2 and 3 is 6, so it will take a total number of 6 steps to become the original string. So basically you got some idea of what is happening over here. uh, so yeah, so you basically got some idea of what is happening over here. Now the question is, how do you how do you solve approach this question? Like, you are clear with what to do, but how do you find out how much time will a string require? So basically what I first did, I defined an array string, and what I did, I ran a DFS on I ran a DFS on the string. So basically, if my string is APAPA and my permutation is 21453, I maintain a array called visited, which tells me of size and which tells me whether I visited the node. So I started from node number 1. I marked this as visited. I marked this as node number 1. And what I did, so I added a to my current string, and then this a, like this element points to b, to index 2. So I went to 2, I marked this as visited, and I made this, so my string becomes ab. Now this position points back to index number 1, but my index number 1 is visited, so I will return this string and add it to my array. So basically I have string ab now. So I have string AB. So I have string AB. Uh, Now similarly, now I will go to 2. Now 2 is already been visited, so I will go to 3. Now, so I will add a to my string. Now 3 is going to, now 3 is pointing to 4, so I will add b to my string. 4 is pointing to 4 is pointing to 5. I will add a to the string. Now 5 is pointing back again to 3, but 3 has been visited. So 3 has been visited. So my other string is this. So now you have to check after how many steps will this uh, 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 string become the same. So here's the trick. So we know that length of our permutation is at max 200. We need to know, like, this is crucial information in this question because it will help us implement. So now we have to check after how many. So basically in every step what is happening, so this string is basically going having taking around a cycle. So ab will be shifted by 1 and it will become ba. So ABA basically takes one right shift and it becomes AAB. So essentially, every time our every step string is being shifted by 1. But when will you know that? So our string will need at least n steps to be come back to what it is. But what if we have string something like ABAB? It will take only 2 steps to become what it originally was. So in order to find the minimum number of steps to see what the string will become, what you can do, so take take a prefix of size I such that n is divisible by I, and multiplied by and divided by. So basically, if we have AB and our I equals to 1, we take the first like the first element and then multiplied it by 4. 4 is basically the size of string divided by the prefix size. And if these two strings are equal, this means that if these two strings are equal, which means uh, like the we will need at least I many steps to get back the original string. So for example, our I equals to 2, so our prefix will be AB. I multiply AB by size of the string divided by I, so it becomes AB. This is actually equal to our original string. So we'll need at least two steps to do this. Now but if you implement this straight away, but if we implement this straight away, there will be one problem. So the problem is, so AB, so we have AB, and our string is of maximum length n. So you will have to, so for checking whether two strings are equal, you will need n time, and you are doing it over n prefixes. So basically, you will need n square time. The number of test cases are 5000, and you are doing it and you are require n square steps in every at least n square steps in every test case. So this overall number will become 10 raised to 8, which will be very tight for a test case to pass. And apart from that, you have to print and all. So basically, there is a don't worry, there is a smart way out. So what I will do, uh, so basically I will run a loop I from 1 to from 1 to n. I will iterate I, not 1 to 1 to n. I will run it from 1 to root n. So what I will do, I will check if I will check if and like the first prefix of length I or n minus I is whether which one of these prefixes uh, prefix when multiplied that many times gives me the original string. Basically, whether I need I steps or n minus n by I steps to perform this. So so for example, AB, I'll take a larger string. So for here I can run the loop in like I can run the loop like I will check for this thing and this thing first. So our answer will be so if our so when I equals to 1, so I will take the first prefix of length a, I will multiply it by it, so it will be a 8 times. This is not equal to original string, so this won't be our answer. But I can check whether the first prefix of length and the length of string by I is it. I will give me the answer. It does give us the answer. So our minimum number of steps required is n by n by 1, that is n. Now when I equals to 2, this is AB. So I will check whether this string will give me the answer, and it does. So a minimum number of steps required is 2. So for every string I will calculate the minimum number of steps required for it to come back to original uh, configuration, like when the string will become original after the operations. And then I will take LCM of all these elements, and that will be our answer. So implementation is there in the description. So yeah, I am yet to solve the question number G. That's why I haven't uploaded it. But yeah, this is it.